Okay, so as I have said, class, that pressure is dependent on the elevation. No? And atmospheric pressure is an absolute pressure unless otherwise stated in the problem. So that is why you must have to memorize the values of atmospheric pressure that is in different units. And so we have here manometer. So a manometer is an instrument used to measure gauge pressure. We have here two types, the simple U-tube or the open type manometer, and the second one is the differential manometer. So as you can see, for the simple U-tube manometer, we have the other end is open to the atmosphere, while for the differential manometer, as you can see, we have the different points. And so these 2 points, of course, A and B, have different pressures there. So in finding for the pressures inside manometers, we will use the concept of the summation of pressures. So in summation of pressures of fluids inside manometer, so of course we will equate the pressures to 0, and we will use this concept, class. In summation of pressure of fluids inside manometer, pressure decreases or negative in going upwards and increases or is positive while going downwards. So we will simply follow this rule. So magkasaka ang atong elevation that is negative nga pressure, so negative rho GH, and magka-ubos gani ang atong elevation, class, that would be positive pressure. So positive rho GH, and then equate na to siya to 0. Okay, so let's say for example, in this simple U-tube manometer, take note that at the end, aning end, which is open to the atmosphere, the pressure here is, of course, atmospheric pressure. Okay, so using summation of pressures, so for this letter H, simple U-tube manometer, we have summation of pressure is equal to 0. Start ka at a certain point, so point A, so pressure at point A, and then we have this fluid at point A, kaning siya nga gray part up to here. So ang elevation niya from this to this is H1. So ni down ka, right? Pa down ka. So gikan din ha to din ha, ni down ka ang imong elevation. So therefore, unsa to basta pa down, increasing pressure, so positive. So, sa imong equation, class, that is positive rho GH. So, rho GH. So, take note, this is for rho 1 and H1. This is the density of fluid 1. So, this one is gamma, meaning to say gamma, diba, is rho G. So, kanin siya rho G. Or that is gamma of fluid 1. Then, times the gravitational acceleration. And then, for our next fluid, we have this interface nila up to dinhi. So, anhi na, kaning yellow nga fluid na to, as you can see. So, gikan dinhi nga elevation, class, up to here. So, the elevation H2, isa ka siya, right? Ang iyang elevation difference niya in the elevation. So, nisa ka siya, therefore, that is negative pressure. So, decrease nga pressure, so negative rho GH. That is H2 ang height, ana niya, and that is for fluid 2. So, therefore, na kay gamma 2, or depende kung unsa nga given in the problem, if it is density ba or the gamma, which is rho G. Okay. And then, minus the last point, class. So, minus pressure at the last point, which is atmospheric pressure. So, minus P atmospheric. So, PA, therefore, so if in the problem you are trying to get for the pressure at point A, so this is now equal to rho 2 GH2 minus rho 1 GH1, and then plus P atmospheric. So, in this case, ang ma-obtain na itong answer for PA is an absolute pressure. So, usually, kung gauge pressure ang pangayoon, so, absolute man eh. So, this is absolute pressure at point A. So, kay absolute man na. So, magamit na sad ka sa concept sa gauge pressure. Payuan ka sa gauge. This is absolute pressure minus P atmospheric. So, therefore, dili ni mo i-include ang atmospheric pressure if pangayuan ka sa gauge pressure. So, that is how you solve for pressure inside the manometer. So, this is for a simple issue manometer using this concept summation of pressures. And then now let us try to solve, or let us try to use also the summation of pressures in this differential manometer that we have. Okay, for this differential manometer, using summation of pressure, still, summation of pressure is equal to 0. Start ka at a certain point, PA. So, magdepende gid siya class sa imuhang illustration, ha? Tingali imuhang let din he is point B ni diri imuhang point A. So, of course, ang imuhang yung illustration is, imuhang yung equation is magbase jud sa imuhang illustration. So, of course, imuha man na siyang, mao man imong gibasihan paggama sa imuhang equation, no? So, dapat dili na buwag sa inyong illustration and your equation. So, meaning, ana na nga pira mo. So, point A, start at a certain point A. So, from this level up to here, you have H1. So, ni-ubos ka, right? So, plus rho 1 GH1. And then, from here, kaninga fluid, taman dire. So, gikan ani nga level, taman din nga level. So, nisaka ka, right? So, that is H2. And then, so, nisaka, so minus rho 2 GH2. And then, so from this level, lain na po ka nga fluid na akay fluid with gamma 3 or density 3. So, in this case, gamma siya. Yung gihatag. So, with the elevation H3. So, kanisa ka man sa negative, gihapon na siya nga pressure. Rho 3 GH3. Okay, so minus pressure at point B is equal to 0. So, PA minus PB is equal to rho 2 GH2 plus rho 3 GH3 minus rho 1 GH1. So, kintahay English units ang gigamit and need nimo nga maggamit ka sa proportionality constant. So, of course, you use the proportionality constant. And so, this part here, kini siya class. So, PA minus PB. Therefore, kani nga part sa ato ang right side of the equation, this part right here. This is now the pressure difference between points A and B. And take note that each term must have the same unit so that you can combine. Now, you can combine all the three terms that we have here. And so, you get the pressure difference at point A. So, kung pangayuan ka sa pressure at point A, so of course, that is just rho 2 GH2 plus rho 3 GH3 minus rho 1 GH1 plus pressure at point B. O, kintahay known si point B, no? Or, that is PA is equal to gamma 2 H2 plus gamma 3 H3 minus gamma 1 H1. That is plus pressure at point B. This is because rho G, the quantity rho G, density times gravitational acceleration is equal to gamma, or the specific weight. That one. Okay. So, this is now your equation. What can you see? This is the pressure difference between the 2 points. This is the pressure at point A. Okay. Now we will move on to temperature. So, temperature is the degree of hotness or coldness of a substance, and is therefore, it is a physical property that underlies the common notions of hot and cold. Something that feels hotter generally has a higher temperature, though temperature is not a direct measure of heat. So we have here the 4 temperature scales. Are you familiar with all these? We have the Celsius or the centigrade scale, degrees Celsius, the Fahrenheit scale, it's usually used in English countries. We have the Kelvin and the Rankine. So Kelvin and Rankine are absolute temperature scales. So Kelvin is the absolute temperature scale for the centigrade scale, and Rankine is the absolute temperature scale na put for the Fahrenheit scale. And we have here the term absolute temperature. It is the temperature measured from absolute zero. So, unsa po ni absolute zero? Absolute zero is the temperature at which the molecules are believed to stop moving. So, we have here the temperature of absolute zero. Okay, so I edited this class since what's written here is a mistake. So, absolute zero is actually negative 273.15 degrees Celsius, or that is 0 Kelvin, since Kelvin is the absolute temperature scale. So 0 Kelvin, that is now the absolute zero. And why is this negative 273.15 degrees Celsius? That is because the relation of between the temperature scales is that we have temperature in Kelvin is equal to the temperature in degrees Celsius plus 273.15, or approximately that is 273. So that is why 0 Kelvin is negative 273.15 degrees Celsius. No? Again, that is negative 273.15 degrees Celsius. So that is the absolute zero temperature. Also for the Fahrenheit scale, ang yahang absolute temperature in Rankine, that would be temperature in Fahrenheit plus 460. And then if you want to convert your temperature in Celsius, to get the temperature in Celsius, so you must have to subtract 32 first. So temperature in Fahrenheit, then multiply it by 5 over 9. And then to get the temperature in Fahrenheit, that is the temperature in Celsius times 9 over 5, and then plus 32. Okay. So this relation is actually derived from the interpolation of the two temperature scales, the Fahrenheit scale and the Celsius scale, using the boiling point and the freezing point of water. So the boiling point of water is at 100 degrees Celsius, while its freezing point is 0 degrees Celsius. So when we say 0 degrees Celsius, 0 degrees Celsius in Fahrenheit, kung atong i-measure ang temperature of the freezing point of water in Fahrenheit scale, that is 32 degrees Fahrenheit. So ang 0 degrees Celsius in Fahrenheit, that is 32 degrees Fahrenheit. So this value, kani siya nga conversion factor, or the relation between this equation is basing on the interpolation using the boiling point and the freezing point of water. Okay, so we have also the term temperature interval or temperature change. So temperature change is change is denoted by this symbol delta. Is the difference between the temperature rating from the same scale and the change in temperature through which the body is heated. So it is always final temperature minus the initial temperature. So if your delta T na ma-obtain is a positive answer, meaning to say that your T2 is greater than T1. So meaning to say, nagka-increase ang imong temperature, no? Your T2 is greater than T1. While if your delta T Ang obtaining mga delta T is a negative answer, meaning to say that your final temperature is less than your initial temperature. So, ang imuhang object or the temperature decreases. So, T2 is less than T1. Your delta T is negative. Then we have your temperature interval or temperature change. So, the relation between the temperature scales in temperature intervals. So, temperature, we have here, temperature change in Celsius degrees. So, for this one, we will put the degrees symbol in front of the Celsius to denote that it is a change in temperature. Is equal to 5/9, the temperature change in Fahrenheit, or that is the temperature change in Fahrenheit is equal to, simuhara siyang i-cross multiply, that is 9/5, the temperature change in Celsius degrees. Also, when we have delta temperature in Kelvin, that is equal to the temperature change in Celsius. And the temperature change in Röntgen is equal to the temperature change in Fahrenheit. That is why, if there's an interval, temperature interval, you can cancel it directly. Say for example, you have T2, T1 in degrees Celsius, in degrees Fahrenheit, in degrees Röntgen. So, in Kelvin pa din. So, say for example, the boiling point of water, we have 100 degrees Celsius. And then, say for example, your T1 is 80. So, what is the difference now? Delta T na to is 20 Celsius degrees. So, kung itong i-convert for this one to 73 plus 100, so that is 373. And then convert 80 to Kelvin, 80 degrees Celsius to Kelvin, that is 353. So that your delta T in Kelvin, that is still 20 Kelvin. So the temperature change in Celsius is just equal to the temperature change in Kelvin. This one. So, kung ito pa ni siyang i-convert further, you will find out that these equations or relations are indeed true. So, you may try to convert this one. Okay, so let us move on. Volume. So, the volume is the amount of space occupied by solid figure. So, in your solid mensuration, you have discussed the different formulas in solving for the volume of different solids, solid figures. So, it is measured in terms of cubic units. So, say for example, in SI, you have your unit cubic meter. In English, you have cubic inch or cubic feet. The volume of any solid, liquid, or gas, plasma, vacuum is how much three-dimensional space it occupies, often quantified numerically. So, masolve maninimo siya. No? Also, let me also remind you, we have the symbol for volume is capital letter V. We have also the term volume flow rate. So, the term volume flow rate, masama na siya. So, what's the difference between volume flow rate and volume is that When we say volume flow rate, so that would be, na-share that sa ibabaw ang symbol, is equal to volume per unit time. So, basta na ganin yung term nga flow rate class, that means that is per unit time. So, say for example, maingon sad kag mass flow rate, no? Mass flow rate, that is mass over time. Basta na ng term nga flow rate, that is per unit time. So that the unit ani karon is in the unit cubic meter per minute baron or cubic meter per hour. Cubic meter per hour. So, inana siyang volume per unit time. So that, kung pangayuan mo sa time, kintahay, pangayuan mo sa time it takes tingali for a cylindrical tank to fill the whole volume niya. So, therefore, masolve nimo na siya if you are given the volume flow rate. You solve for the volume, divide by its volume flow rate. So, makuha nimo ang time depende in minutes baron or in hours. So that is volume flow rate. And next is the density. Density, by its simple definition, by the way, the symbol of density is rho. Its simple definition is equal to the mass per unit volume. Okay, so by knowing the definition of these quantities class, you will have like a hint of its correct unit to use. So, mass, unit of mass, kilogram, and volume in cubic meter. Okay, and then this is, in English, is pound mass per cubic feet, or you can also have pound mass per cubic inches. So, that's why. Next would be specific weight. So, this is what we were talking about earlier, no? Gamit na to ang density and specific weight. And specific weight is denoted by the symbol gamma. By the way, it is also called as the unit weight or the weight density. Kitawag sa siya o weight density. Weight density. So, the symbol of this is gamma. Gamma is the weight per unit volume. So, mo nang gitawag siya weight density because ang density is mass over the volume. Ang weight density or the specific weight is weight over volume. And so, weight, we can also obtain weight by this formula, right? Mass times gravitational acceleration over the volume. And so, kani siya, nga quantity, mass over the volume is density. That is why we have the formula, we have the relation for gamma that is equal to rho G. So, kani siya. Ang unit niya class is in the unit Newton per cubic meter or in weight. In English unit, that is pound force per cubic inch or pound force per, so unit of force over the unit of volume over cubic feet. So these are its units. Next we have specific volume. Specific volume is denoted by small v. This is the volume per unit mass. This is small v. Volume per unit mass. So, you may notice, it's simply the reciprocal of density. Diba, density is mass over the volume. So, this is volume per unit mass. Therefore, it is the reciprocal of density. So, unit niya is reciprocal, put siya sa units of density. So, unit of density is kilogram per cubic meter. So, kini siya cubic meter per kilogram, cubic inch per pound mass, or cubic feet per pound mass. Next is specific gravity, or this is SG, specific gravity, or also called the relative density. Tawag sa siya relative density. So, relative density because we will use a standard substance ratio of its density, the density of the fluid to the density of the standard substance, or the ratio of the gamma of a fluid to the gamma of the standard substance, to which our standard substance to use is water. So again, Sg is the ratio of density of the fluid to the density of the standard substance over the gamma of the fluid to the gamma of the standard substance. And so since it is a ratio, your units simply cancel, so therefore it has no unit. Your specific gravity has no unit. And so many sa standard substance na to, as I have said, we will use water. So water at the standard density of water at 4 degrees Celsius, or for fluids at 15.6 degrees Celsius, we have 1,000 kilogram per cubic meter. So you must know the standard value of the density of water, or in English unit, that is 62.4 pound mass per cubic feet. Also, the gamma of water. So, saan ito ng gamma? Gamma, diba, is the product of rho G, no? Ang sa itong gingon, gamma is rho G. Therefore, kung magkuha ka gamma sa water, that is simply 1,000, which is density of water, times 9.81. This is 1,000 kilogram per cubic meter times 9.81 meter per second squared. So, it is now the gamma of water. That is 9810 kilogram meter per second squared is Newton per cubic meter. So, 9810 Newton per cubic meter, or that is 9.81 kilonewton per cubic meter. Now, for the English unit, we have gamma of water is again rho G. So, rho 62.4 pound mass per cubic feet. Then, gravitational acceleration 32.17 32.174 feet per second squared. And so, dapat ang ma-obtain nato ani nga unit should be, sa to unit sa gamma, should be in weight unit, pound force per cubic feet. So, mo niya dapat ang unit na ma-obtain nato for the gamma of water. So for this one, dili ta maka-obtain, no? So, mo na nga, we will use your proportionality constant K. So, you use the value of K, which is 32.174. The value of K is pound mass feet per pound for second squared. Pound mass is cancelled. Feet per second squared cancel. So, you get now the unit pound force per cubic feet. Okay, so, okay na. Obtain na to ang unit na pound force per cubic feet. So, as you may notice, 32.174 is also cancelled. So, this is 62.4. So, as you can see, same numerical value with its density, but the unit is, this is pound. Take note that this is pound mass per cubic feet. This one is pound force per cubic feet. Mass yan. Okay. So, this one, since standard lang man ta, standard ang ato ang gravitational acceleration. So, that is why it is cancelled directly. Okay. So, specific gravity is very useful. Say, for example, wala kay density of the fluid. So, density of the fluid, therefore, tagaan ka sa specific gravity. So, multiply that one with the density of the standard substance. So, specific gravity of the fluid times the density of the standard substance. You get now the density of the fluid, specific gravity of the fluid. So you must of course know the density and the gamma of standard substance, which is water. So you have to be familiarized with these values of water. Next is viscosity. So viscosity, we will simply have the definition of viscosity, since you will have further discussion about viscosity when you have your fluid mechanics. It is the property of a fluid that tends to prevent it from flowing when subjected to an applied force. So high viscosity fluids resist flow. So sa ko na to? High viscosity fluids resists flow, while low viscosity fluids flow easily. So low viscosity. So meaning to say, since taas mo siya viscosity, dako siya internal friction, no? Fluid friction. So that is why it resists flow. While low viscosity fluids such as water flows easily. So again, you shall have more of this about viscosity topic when we have your fluid mechanics. So I guess that would be all for today. Thank you.